In this video, we want to prove the following property of logarithms, and you'll be using the definition of log along with properties of exponents. If you want to try this, go ahead and pause the video. Otherwise, I'll proceed here. This is what we want to show. We want to show that the log to base a of m over n is equal to the log of the numerator to that base minus the log of the denominator. And it's understood that a, m, and n are positive, and they cannot be 1. So one way we can do this, let's look at the log of m to base a, and let's set that equal to x. Now this will imply, by the definition of logs, that m going from log to exponential form, m is equal to a to the x. In the same way, if we look at the log of n to base a and set that equal to y, and again there I'm just using substitution, and then in the next step I'm using the definition of a log, going from log to exponential form. So this implies then that n is equal to a to the y. So then I'm just say, okay, let's look at m over n. What is that equal to? M over n. By the substitution we made, m is the same thing as a to the x. I'll put this in the numerator. And n is equal to a to the y. So let's look at this right side. A to the x over a to the y. Using the laws of exponents, properties of exponents, we bring down the base. When dividing powers of the same base, we bring down the base, subtract the exponents. So this is going to give me a to the exponent of x minus y. So now let's look at this here then. M over n is equal to a to the x minus a, and a is your base. So you can look at this statement right here. Let me write it over here. M over n is equal to a to the x minus y, and that's an exponential form. So go back the other way to put it back in log form. What does this mean? This means that the log, this implies that I can write this next statement here. The log of m over n to base a should equal to the exponent of that base a, which is x minus y. Now we can go back to the substitution over here. This one and this one. We know that x is the log of m to base a, and minus y, and y is the log of n to base a. So we've proved this statement, or justified that this statement is true. We have the log of m over n to base a equals to log of m to base a minus the log of n to base a. And of course you use this property along with other properties of logs to solve equations and related problems. This is showing you how they're derived. Everything in mathematics was either derived or proved by some mathematical method. Thanks for watching. We'll see you next time.